Hey everybody, this is Larry. This is day 19 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button. Ooh, that's the one button. Join me on Discord. Let me know what you think about today's problem. Just today's problem. I already did the extra problem, so we'll take a look at today. It's 931, minimum foreign path sum. Alright, given an n by n matrix, array of integer matrix, return the minimum sum of any foreign path through matrix. I think I talked about this problem at some point in the past, but we'll talk about it again. It has to be just diagonal, right? Because actually I guess it wasn't. It has been a while, but yeah. I mean, this is dynamic programming. Obviously, if you haven't been here with me, so I'm gonna go from the start. This is gonna be dynamic programming. The idea is that you can kind of parameterize the best current state based on the previous row, right? So you could kind of even say it in plain English. For every cell, it is just the minimum of the last three above. This is also like very endearing to me. This this particular dynamic programming, or at least this particular frame, is that it's very meaningful to me because I think this was one of the earliest usage of dynamic programming that I've used in quote unquote in real life, though it was as a side project. Because if you ever used Adobe Photoshop or something like this, nowadays you may, there are a couple of ways to scale a photo, right? And basically the idea behind scaling a photo, like the naive scaling, is just like if you make the photo half the size, then everything just like shrink by 2 and so forth, right? So that's one way to scale. Another way to scale, of course, is this thing called content-aware resizing, right? Without going over how to do bigger, but if you go smaller, there is this ratio scaling thing that we just talked about. But another way is actually this thing called I forget what the name is specifically, but it's like minimum energy removal or something like this. I forget what it's called, but I think the technical term. But basically, the idea is that you can define each cell and or each pixel, right, as red, green, and blue. And of course, also, by the way, if you don't want to hear about this, you can fast forward. But it is interesting in case you sometimes ask like, will these always be practical in real life or whatever? So I'm giving you one example, one that, like I said, is endearing to me. But basically you can think about each pixel as, red, green, and black, or sorry, red, green, and blue, RGB, and also an alpha channel if you want to play with that. Though I think back then, I would say that I don't know that there's alpha, but alpha being like the transparency of that pixel, right? And instead of like everything on each cell, you can also you can calculate the minimum sum, if you will, of all these things, but not minimum on the colors, but basically minimum on the change in color, right? You could say that, for example, if you have two blues in a row, then you could say that maybe the delta is 0 or something like this. Where if you go from like a green and a pure green to a pure red, you can do some what's it called? It's not Euclidean distance, but like the D2 distance, right? Like, delta R square plus delta green square plus, delta blue square, and then you minimize that, something like that, or the square root of that maybe, right? So like some distance metric, right? And the logic there, if you want to go back to the logic, is that, well, you want to take the line that has the minimum changes because those are the things that are not interesting, right? Let's say you have a picture of myself, like Larry, and a blue sky. You don't want to remove, if you want to remove, say, one line of pixel, like one vertical line, you don't want to go up, down the middle, and then maybe I have a smaller nose now or something, right? But what you would do is that if you calculate, and let's say I have maybe not here, but let's say I have a black or a blue sky background, then you just take a random line that is on the sky, and then basically you just shrink the sky behind me. And maybe there's a tree, maybe there's the sun here, and then it'll just take a line that doesn't have the sun or something like that. So something like that is a very practical use of dynamic programming back in the day. And not even that, it's just that it's very visual, right? Because there's a lot of because I remember another project I used to do with dynamic programming is a lot of well, simulations, but also like sports based states, right? Nowadays, I think actually like to be honest, I wish I knew enough to publish or something like this back then, because I had all these ideas before a lot of people did because of my dynamic programming and stuff like this background. But for example, I'll give you an example is like baseball, right? Baseball is very easy to make discrete because basically you have like outs, you have innings, you have the score, and who's on base. I mean, that's a very easy state. Obviously, you can make things as complicated as you want with like other dimensions. But yeah, but based on that, you could have like expected win kind of thing. And then you could kind of do all these math backwards. And all of this is just based on dynamic programming, right? Because you have like a probability of, like if Larry is up against, I don't know, some pitcher maybe has 20% chance of getting a hit, you have a 20 whatever, and maybe another one would be cricket, maybe if I knew cricket back then. But just to give an example of like dynamic programming and states, and that kind of math actually like not discovered by me, I just kind of like was playing around with things by myself, and wish I published. But like that kind of thing actually revolutionized sports right now, right? Like everything is about sport, that kind of thing, even if it's not quite the same. Like there are other ways to do, there are also like linear regression models and stuff like. So there are different ways to kind of model these things in like basketball or American football or something like that. Anyway, so that was like a long time ago. I'm not going to even say how long to age myself even more. But yeah, it's basically Moneyball before Moneyball, kind of, right? Like that was how long ago it was. Anyway, that was a very long rant, but hopefully this problem is straightforward to you. It is really one of the more basic dynamic programming problems. The reason why I like to kind of tell the story every time is because you're able to visualize it and kind of see it every time, right? Like it's a very easy abstraction about like how to kind of do it, and the thing of dynamic programming and also competitive and a lot of these Leetcode problems in general is that a lot of these things are abstract, but that's like a very real thing that you can actually implement yourself. And if you really if you have time and you're looking for a project, or like not a project I guess, but if you want looking to play around, you can implement this in I don't know, half an hour and an hour, because I know that Python now has a lot of like UI libraries. I'm not familiar with them, so so if you have everything set up, you can set this up very quickly, right? Like put in a picture, make a command so you remove like 5 vertical lines or something, right? Anyway, story time is over, so that's what I have for the story time. But let's actually kind of get around this problem. So let's set up. As you go to matrix, cannot type. I just came from the code up from outside, so my hands are a little bit frozen a little bit, so I gotta, warm them up. But yeah, so for R in range of R, right? I guess I guess a lot of the times I write these problems, I do it top down for learning. But this one I actually, in general, very much like to do bottoms up. It's not even bottoms up, to be honest. It's just tabulation in a because I like to do it downwards as well. Though it doesn't really you could this is also another problem that if you watch yesterday's video that I talked about with respect to yesterday was a very easy climbing step, so also another fundamental problem. So maybe we're just getting fundamental DP this week, but one thing to know about this particular problem is that it is also symmetric, right? And what I mean by that is that the minimum sum going from the top to the bottom is going to be the same as the minimum sum going from the bottom to top. So it gives you more leeway with how to write this, but it's also worth pointing it out, right? Because it is not always true, and you don't want to you want to be mindful for problems that when it's not true, you're looking for the other way, right? And still solve the problem. That's the biggest thing. So yeah, so basically here we can maybe say best is equal to is it minimum? So let's just say infinity, right? And let's just say C is the length of the first row. Right? Yeah, and then now for each row, for each column, then did I just set this up a little bit better? I guess I do. Because okay, so the first row is just best of row of C is just equal to the matrix of 0C, right? And then now we start. Oh no, not on the first row. And on the first row, it's just going to be equal to the min of the previous row. Oops. The same, just directly up. This is always awkward to write because, oops, I keep making the same mistake. Because this could go out of bounds, right? So you have to kind of write something like, oh man, how do I keep writing that? I don't know why. But yeah, and then if best or if C minus 1 is greater than 0, then C minus 1, right? It's less than or, and I cannot type today. Right, so something like that. And then of course you have to add in the values, so then after that you can just add in the right? It's the min of these three things. Maybe I wrote this in a weird way. So, or maybe the way that I would write is that maybe I would just call this minimum previous. I mean, it's accurate, but maybe it's a little bit obtuse. Right? Because then now you can write something like C is equal to the previous min plus the current cell. And then now at the end, we just I just want to mentally check that it works for negative numbers. I actually didn't realize it was negative numbers, but yeah, otherwise then it just returns the minimum of the last row, and that's it. In theory, what would I do wrong? I mean, the good thing about DP is that you can always print everything out. Maybe I have it off by one somewhere. I don't know. So 2, 1, 3. Okay. So the 6 is going to be 1 or 2. Oh, yeah, I just have typos everywhere. Huh. Because this is the last row, right? Right. Not a big deal, but this is why, printing is the best debugging tool, if you ask me. I don't know, but yeah, it looks good. Let's give it a submit. And yeah, I didn't make a mistake. Why did I get wrong answers last time? Oh, maybe I just clicked the submit button by accident because I didn't even finish typing. Oh, this time. Don't know. Oh, maybe I just didn't consider negative values or something. Is that it? But yeah, this is going to be all of, this is linear time, linear space. And when I say linear, I mean R times C, because R times C is the size of the input. Of course, you can actually optimize the space even further to be sublinear, to be O of C, by just keeping track of the previous two rows, because you can notice that here we only care about the last row and the current row, obviously. So now you only care about 2 rows, and then after that you could throw away. So if you kind of use that, you can reduce this to O of C space. But yeah, as I say, this one is pretty fundamental, pretty straightforward. You just have to know it, right? This is really basic dynamic programming, and if you're able to, even if you understand it, you should be able to get this very quickly, to be frank. Oh, actually, and I forgot that this is n by n. I mean, mine is more general, but it doesn't really matter, I guess. But yeah, but also just to be clear, you have to be careful because if I had read this correctly, I would have said this is n squared, but n squared is still linear in this case because n squared is the size of the input. So don't get confused, or just say n squared, I guess. Then you don't have to say whether it's linear or quadratic, but it is linear in the size of the input. That's what it is usually shorthand for. And the size of the input is n squared. So yeah. Anyway, that's all I have for today. That's all I have. Yeah, let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.